We are going to walk through some examples where we'll need to take the derivative of a natural exponential function. Let's look at our first example. In this example, we're asked for what value of x does y equal 2e to the x minus 2x have a horizontal tangent. I think the hardest part of this problem is trying to figure out what you actually need to calculate. So let's look at this again. For what value of x? So we need to find x where our function has a horizontal tangent. A horizontal tangent is going to happen where the slope of our curve is equal to 0. So that means we want to find x where our slope or our derivative dy dx is equal to 0. This means that the way we're going to start is by finding the derivative and setting it equal to 0, and then we're going to solve for x. Let's go ahead and let's take our derivative. Dy dx is the derivative with respect to x of 2e to the x minus 2x. This is 2 times the derivative of e to the x, which is just e to the x, minus the derivative of 2x, which is minus 2. And we need to set that equal to 0. Let's go ahead and let's pull the 2 over to the right-hand side. So this is 2e to the x is equal to 2. Dividing each side by 2, we get that e to the x is equal to 1. You may know by looking at a graph of e to the x that e to the x is going to be equal to 1 when x is equal to 0. If you don't know that, one way that you can solve this is by taking the natural log of both sides, because that will get the x out of the exponent. This then is x times natural log of e is equal to the natural log of 1. Then we have to know that the natural log of e is 1. So on the left-hand side, we just have x. And then we have to know that the natural log of 1 is equal to 0. So we get x is equal to 0. I have a video on the natural exponential and natural logarithmic function that you may want to look at if you're rusty on exponentials and logs. Let's go ahead and let's highlight our answer. This tells us that our curve has a horizontal tangent at x is equal to 0. I went ahead and graphed this curve just so that you can see this. Do you see that right here at this point, x is equal to 0, we have a horizontal tangent. Let's now look at our second example. For this problem, we are asked to find at what point on the curve y is equal to e to the x is the tangent line parallel to the line y is equal to 2x. Let's see if we can figure out what we need to do. We want to find at what point on the curve. That clues us in that we need to find x, so let's write that down. We want to find x, and we want to find x where the tangent line is parallel to the line y is equal to 2x. If two lines are parallel, that means they are going to have the same slope. So we're going to find x where the slope of y is equal to e to the x equals the slope of y is equal to 2x. Remember that the slope is the derivative of the function. So we can say that the derivative with respect to x of e to the x has to equal the derivative with respect to x of 2x. The derivative of e to the x is just e to the x, and then the derivative of 2x is 2, so we have e to the x is equal to 2. Now, we need to solve for x, and the way to get the x out of the exponent is to take the natural log of both sides. So this is natural log e to the x is natural log of 2. This is x, natural log of e is natural log of 2. Natural log of e is defined to be 1, so we have that x is natural log of 2. Now, let's go back up and look at what we were asked to find. We wanted to find what point on the curve. Normally, when you're asked to find a point, that means you need the x value and the y value. So let's see what our y value is. Our y is equal to e to the x. So this is e to the natural log of 2, and that's just equal to 2. So our point is natural log of 2, comma 2. That's our x value and our y value. I graphed both of these functions just so that we can understand our answer a little bit better. We found that the slopes were the same when y was equal to 2. That occurs right here, and that corresponds to this point about down right here, which is actually natural log of 2. Let's look at our next example. For this example, we are asked to show that the curve y is equal to 2e to the x plus 3x plus 5x cubed has no tangent line with slope equal to 2. Let's remember that the slope of the tangent line is the derivative. So we're asked to show that the derivative dy dx is not equal to 2. So there is no tangent line with slope equal to 2. Let's go ahead and let's take our derivative. Our derivative dy dx is the derivative with respect to x of 2e to the x plus 3x plus 5x cubed. We're going to break this into pieces. We can always pull the constants out in front. So this is 2 times the derivative of e to the x, which is just e to the x, plus 3 times the derivative of x, which is 1, plus 5 times the derivative of x cubed, which is 3x squared. So this is 2e to the x plus 3 plus 15x squared, and we need to show that that is not equal to 2. That's actually really hard to do. You know what is easier is if we can show that an algebraic expression is not equal to 0. So I am going to pull the 2 over to the left, and this gives us 2e to the x plus 3 plus 15x squared minus 2 is not equal to 0. We can combine the 3 and the minus 2 and write this as 2e to the x plus 15x squared plus 1 is not equal to 0. Now let's look at each term separately. E to the x is always greater than 0, so let's write that down. So this is greater than 0. X squared is greater than or equal to 0, so this is greater than or equal to 0. And then our 1, of course, is greater than 0. When we add these three terms, we get an expression that is greater than 0, and that tells us that it is not equal to 0. So we have shown that 2e to the x plus 3 plus 15x squared cannot be equal to 2. I actually took this expression right here and I graphed it because I wanted you to see that that expression is definitely greater than 0.
If this video has been helpful to you, please consider subscribing to my channel. Keep believing in yourself and have a great rest of your day.